Hey there, it's Jeff with Giroux Camping Adventures. Today I'm going to show you how I install an onboard air system in this 2020 F350. Let's get going. Hey guys, this is the exciting part for me. Right here is all the electrical stuff that I'm going to use. So I'll give you a quick rundown. 2-gauge wire that's going to run from the engine compartment to the back of the bed. It's going to connect into these bus bars. I'm going to use a 120 amp breaker in the engine compartment, which is going to be on the positive. Tessa heat tape, which is electrical tape substitute. Some heat shrink, my tools of course, the necessary wire lugs, and I have 14-gauge wire as well. Those are going to go to the upfitters. All right, here's the conduit I'm going to use. 1-inch interior diameter, which will fill with negative and positive 2-gauge wire with some extra runs of 14-gauge going to the upfitters. And then I'm gonna have this 1/2-inch conduit for things like the airlines and separate runs of the 14-gauge wire. Got this wire on the ground. I have 2-gauge for positive and negative that's going engine bay to right around here in the truck bed I'm mounting. These 14 gauges are upfitter switches, one for the compressor, one for the air horn solenoid, which is right under here, and I'm going to run another one just for extra and future. But first I'm going to use this wire to see the length, because I got that 1-inch conduit and I still have to figure out how to jam it into the engine bay somehow. So here we go. I ordered 1-inch and I also ordered 3/4 inch. If you put 2 wires of 2-gauge in there, it expands the conduit a little bit. And since I'm going to try to plan on putting these upfitters in, that's 2 big ones and 3 little ones, I went with 1-inch. So in case you're wondering, go with the 1-inch interior diameter for 2-gauge wire. Now we're in the engine. The goal is to connect to positive and then connect to negative. Normally, like in an RV, I would just run a positive, but after reading and doing some research, I don't know what kind of chassis ground they have going through the frame and where it connects. So I'm going to run my own negative to the negative terminal, and that's going to go all the way to the bus bars. But the tricky part is putting it in here. Second, I have to find a way down into the wheel well area and then through the passenger frame. So that's the goal. My upfitter switches are using 14-gauge Anchor marine grade wire, 100 foot. So I'm going to put this in the bed and run this as my sizing wire, snip it, and then I'll know the rest of the length. The train horns, right here. The big horn, and that has the solenoid valve, and then the medium and the small, and they have some connectors to connect to this. And make sure you leave enough room to get up into the solenoid valve. That's where we need to cut. This extra upfitter that I'm leading all the way to the back of the bed is 22 feet. This is the upfitter for the compressor, 17.5 feet. This is going to be my second upfitter, which will match the length of that one. So let's do another one. Three runs of upfitter switches. Now, how do you tell them apart in a bundle? You got to prep that. Otherwise, you're not going to know. So what I'm going to do is put some heat shrink on the end. On one, I'll put red, one, I'll put black on both ends. The other one, maybe I'll do red and black. And that way I know each end belongs to upfitter 1, 2, or 3, and I don't have to guess. I'm back from heat shrinking. One wire, the longest one, has a red and black heat shrink. The other one is black, and then the other one is red. Every once in a while, I'm gonna use a Sharpie marker and put a single, double, or triple mark every couple feet. And then that way when I open the conduit, I'll know. So not only do I have the heat shrink, but I'm also gonna have markings. Here's my wire loom. I'm gonna end up putting Tessa tape, which is heat tape, like electrical tape. I'm gonna start right about here and go about 5 feet down. All right, guys, it's late at night. I gotta whisper. 3:30 a.m. almost. Here's the final product. Tessa tape for about 5 feet down and about 18 feet of conduit. Here is my roughly 18 feet of wiring harness. This is going into the engine bay, and I started my tape here. And after looking through all the Ford wiring, everything is taped. So I'm gonna tape everything else, and then right about here, maybe 2 or 3 feet back, I'm gonna split off a Y, because that's gonna go to the train horn solenoid. All right, let's size some more wire. This is gonna be the negative going to the horn solenoid. Get the wire. I taped the bus bars up temporarily just so I can see how they're gonna look. If I mount any of them back here, I'm gonna have to go with self-tapping screws because there's hardly any room. There's actually no room to get my hand back there. So I think it's best if we put one here, and then I was gonna put one down there at the corner. I'll tape it up again, and then I'll show you what it looks like. All right, one look at the final taping. We have a negative bus bar and a positive. The train horn mounts go into these bolts here. Nothing else is above, so we're safe to mount there. And then this curve in the truck lets me drill in and safely not hit the bells in the back. So let me show you the bottom. This first curve will be the negative bus bar. Looking by the light section above the train horn mount will be the positive bus bar. And doing it from the side, I'll be able to hold a nut so I can tighten from the back, and I think that'll be more secure than self-tapping screws. Hey guys, unfortunately, I don't have the right hardware to do the mount I need. So I need to go to the hardware store, and I will be right back. Here we go. All right. I have my hardware. Everything is stainless steel, so I have lock springs, washers, and I have nuts. Some 1/4 by 20 thread, and then I have fender washers. The air lines are exposed, like the holes for the push to connect, so I'm gonna put a little piece of tape over those, and then any of the metal shavings that fall won't get inside the airline. All right, there's my handiwork with some paper towel spread from the left side to the right, covering the horn. Then each horn valve is covered with some masking tape. Hey, after some sizing and double checking some things underneath, I'm gonna mount them both vertical instead. I have them temporarily hung up. I'm gonna have a helper hold this side, and I'm gonna go underneath the wheel well and tighten from the bottom. Yeah, here's my helper. I haven't started yet. All right, hold on. Right now, I'm gonna mount the circuit breaker. Let's go. Hey, check this out. I don't even have to drill. I can use the battery bar lockdown, and one bolt should be good enough. I can prop it up against this fuse box to keep it from spinning more, and the force of the bolt should keep it secure. For battery maintenance, I just loosen the bolt. As long as I have enough cable and I can slide it up a bit, I should still have access to my battery. This is the battery connection on the breaker, and this is the aux. So this is the one going to the back, this is the one going to the battery. So I will make a small little cable from battery terminal to breaker, and then my 2-gauge wire will come up through the engine and connect to here. Last night I was trying to find a good ground location coming off the passenger negative cable. The terminal lug had two cables coming off. One was a smaller gauge going right to that hood body area. The other one went to a bundle and caused me to take apart the battery bucket and everything to see where it went. It formed into the bundle with the positive and the rest of the wiring coming from passenger to driver side. On the way down, there was a negative cable coming off onto the passenger frame rail, and as the bundle continued, there was a 2 gauge or maybe bigger hitting the engine block. In the process of putting everything back together, maybe the system reset for the floorboards that come out. So currently we're going to do some troubleshooting first, because radio works, doors work, seating works, but the floorboards don't pop out. And you missed it on camera, but it caused a spark on accident. So I may have blown a fuse. Hopefully I didn't kill something. Let's dig in, we'll see. Oh. All right, it's a pain to get in without floorboards, even for me, I'm pretty tall. First step, let's just check memory settings. Maybe we'll look out and things got reset. All right, hit right until you go through your settings. And let's pick gauge. Right now I can see that the DEF fuel is something I used to have in the top right, and it's been reset to turbo. So far, that's a good sign, because that might make overall this troubleshooting step easier. So let's put DEF back on, and that looks good. Advanced settings, vehicle. Power running boards, here we go, here we go. Ready, guys? It says off. Put it on auto, and there they go. Oh, the neighbors are jumping for joy. Watch, off, out. Woo, it's like magic. Much better. No more troubleshooting, we fixed it. Let's move on. All right, now that the memory settings are back, let's go test some potential ground locations. We can test for resistance, continuity with your tester, and we can also test for voltage. I'm gonna use these clamps so I can extend from the battery down to where I'm able to reach various locations. On the end of your cable, you can cut it and expose the wires, and then that way you can put them in your lead. Let's get started. First, test your tool with your normal leads, make sure everything works. 12.3, that's good. The truck's been off for a few days. Coming off battery negative, this is chassis ground to the body hood area. This is ground number 1. All right, now we are under the front right tire. This is the passenger side frame rail, and there's a ground right up here bolted at the top. This is the passenger frame I was talking about, and this is the negative chassis ground coming out of this big bundle. And look at how puny that cable gauge is, you guys. This is why I'm trying to find a nice suitable ground location. You also want to think of convenience, so anytime I have to go do maintenance or pull that cable, that's going to be a pain if it's in a bad spot. Let's keep digging. Continuing along the passenger frame, you see this big bundle, and it goes up into this plastic tray, then has a black negative cable right there on that engine mount. That's your engine block negative ground. There's a few other potential ground locations on the engine with these nuts that are coming out. I'm going to test those various locations with a voltmeter, and let's get a reading. Once again, we're going to test voltage, and then we'll do resistance. Put your positive lead on the battery positive terminal, and then I'm going to try to test one of those engine bolt locations. All right, that one says 12.4. Switch to resistance. We'll move positive lead to the negative terminal. Put this back on the engine block, and now when we test, we'll be testing resistance. And this should be 0.1 or 0.2 as well. Practice safety and protection. I should have goggles on, but my only ones are dark and I can't see at night, but that's no excuse. This bolt and these set of bolts is holding up some brackets. And this one's free and this one's free. So I'm gonna remove it, and then I have some sample 4 gauge with some wire lugs on it just to see what it looks like. So we're gonna test real quick. Here's a look at the engine block mount location and my test 4 gauge wire and how it would look going back down to the back of the bed. Hey guys, I'm doing all this extra hard work because Ford says on the 2020 models and above, there's a BMS system, a battery management system, and not to connect directly to the negative terminal for your auxiliary devices that you do an add-on. These other ground locations that I'm pointing out are with thinner gauge wire, and usually you want your current flowing on evenly sized wire, positive and negative. The BMS is this little sensor right here. It's acting as a clamp, so if you go directly to the negative, you're gonna bypass this, and that's what the warning is in the book. I think it's better if we get a good ground location anyways, because I don't trust these little ones, especially if the compressor or anything else I add to the back of the bed is pulling high load. If there's a problem with one of the other grounding straps, like the engine block, and current tries to flow through another grounding strap like this, and the load is too much, that's bad news. I gotta get started on this wiring harness and finish the wrap all the way up to about here, and maybe about 2 feet down I will create a Y with some 1/2-inch conduit. Let's get started. The wiring harness is now wrapped. 1/2-inch conduit as a Y. This is the rest of the 1-inch with the rest of the wiring and the bundle. 2 gauge, an extra upfitter, the negative going to the Y of the horn solenoid. And this is one of the upfitter 14 gauges running through the 1-inch conduit. We have about 6 feet from this section going forward, which gets us 3 feet into the engine, about 2 to 3 feet over with some mounting spots. Guys, let's weigh this harness. Let's see how much it weighs so we can subtract that from the truck payload. First, we'll weigh myself. 163.8. All right, put this on. Let's see how much I weigh with this Anaconda wiring harness. My Anaconda don't want none. 175, roughly 11, 12 pounds. Sweet, not so bad. All right, looking at the point of entry for the wiring harness one more time, and you can see there's a little gap right in there, and it's big enough for the 1-inch conduit. I've stuck it through multiple times, and hopefully this is going to be the last time we pull it through. We'll zip tie it and cinch it in the back as well. Here we go. Send the wiring harness from the back of the bed first. I find that easier. Remove that cap at the front, and that'll make the hole bigger. There's also some rough metal edges in there, and that's why we have conduit and we taped it. There's the 1-inch conduit coming out. We wanted that side of the frame so that way we can keep it secure and ride along the top here. All right, this is a pain. Maybe you should go from the other side, but I've already started. I'm committed. Remember, there's some rough edges coming out of the truck and then rubbing against the cab frame right here. This is where you want it, behind this mount for the cab. Oh, right now it's really stubborn though. I'm trying not to ruin my conduit and good tape job. Here we go. Now we got it coming out. Once you have enough and you know it's hanging down, you should be able to go back to the top and get the rest. Quick reminder, if you removed the cover, make sure you slip that back over the wires before you connect them to the bus bar. Otherwise, you're gonna have to remove the connections from the bus bar and run the wires in here. So let's do that real quick. All right, there's the conduit running along the passenger frame, on the ground technically. Pull this out so you have just enough room to put your wiring harness in it. You're gonna form a hook. You could tape it and secure it to make sure the wire bundle stays, and then you're gonna fish it back up the other side. All right, here's the harness run. There's the positive and the negative. This is plenty of room for the 2 gauge. Upfitters go into the bundle right under here. Now, if we go check out underneath, it's riding along the top of the frame rail and then it comes out the truck. This is good. I'm gonna shove this back, push this down so the Y is back behind the wall. The leftover of this cable should be plenty to make connections to the bus bar and connections to the electronics. All right, looking under the truck, here's the Y split off. It's gonna run to the horn solenoid. I'm gonna cinch up everything along the passenger frame with zip ties going along the frame and up the wheel well area into the engine bay. I'll be able to make my connections, get rid of the extra wire. I'm gonna use these stainless steel zip ties to attach the 1-inch conduit to the frame rail, and I'll do that in multiple spots. And I have a bunch of plastic zip ties as well, so I'm gonna use those along various places too. I don't want this to fall down during travel. That would be bad news. Make sure things are secure. All right, here's the final run of the wiring harness. It comes out with plenty of room right down there. I was able to get a couple pieces of zip tie. Coming down from the engine bay, you can see the conduit. A few pieces of zip tie there. Some steel zip tie here. Goes around this bracket holding up the cab. The zip tie a few more places and works its way down. Here's the conduit sitting on top of the frame rail. These are the last two steel zip ties. Here's the Y conduit. I'll zip tie that later. And let's go into the bed, I'll show you. Here's a look in the truck bed with the rest of the wire loom. It's gonna get cut right about here, and then the rest of the wire will be exposed and make its way into the bus bars. This upfitter that we see here is for the compressor relay, and then the compressor power will also go into the bus bars. The 2-gauge wire will be clipped shorter, and that will be into the bus bars as well. All right, that was a lot of work. We have the wiring harness done, it's all wrapped, it's run from front to back, and it's also zip tied. Yes. Today's goal is to shorten these wires and attach them to the bus bar. I'm gonna cut the conduit, I'm gonna cut the cable, I'm gonna make some wire lugs and heat shrink. Let's go. All right, point of no return, time to cut. I made a little mark here, but just in case, I'm gonna go up a little bit further. I can always cut more later. You can't get cable back. These are really good cutters, Klein tools. I use these on 1/0 wire, and this is 2-gauge. No problem cutting through that. At this point, you're gonna size for the wire lug. You wanna make sure you have all the copper available to fill the whole hole. That's funny, the whole hole. Go like this, see where it matches up to the tip, and then you're gonna wanna cut the sheathing off at that section. You should feel some resistance as you get through the insulation. It's gonna feel hard. That hardness is the copper. You wanna stop right away. All right. So that's exposed copper. Take your lug and make sure all the coils, all the strands are inside. You don't want anything on the outside. That's a good fit. Heat shrink tubing. 3-to-1 heat shrink. We also have 2-gauge wire lugs. Make sure you cut your heat shrink, put it on first, then your lug, then you crimp, then you heat gun it. All right, this is a TEMCo crimper, and you can see all the different sizes. I don't know if you can see it with the reflection. There you go. And what I need is 2-gauge. So spin this wheel until it gets to the 2-gauge section, right about there. And now when I open and close, the crimp inside will form a 2-gauge. Hey, make sure your heat shrinks are all consistent in length. Get a tape measure and measure about 1.5 inches, and that should be plenty to cover the lug and attach to it, and then attach to the wire and secure it. Double check the orientation of the wire lug before you crimp it. Once it's crimped, it's not going to spin anymore. My particular crimper, the die punch is going to go in the top. Get it centered right about in the middle. Hold on to your wire and push it through. Make sure it's tight. Once it's in enough, you can use both hands for more stability. The die pushes down really hard here and it forms a triangle shape. Pull on that wire and make sure you cannot get it out. Make sure it doesn't twist, and that's a nice solid connection. When you put the heat shrink over, it's gonna look nice. Let's do the red. All right, there's a temporary look at the wire lugs. Heat shrink, wire lug. There's a little bit of glue seeping out on each side. All that is exposed right now is the tin plated copper lugs. Here's a look at the completed bus bar location for the positive and negative. I came out of the conduit and I did a little twist in order to make an easier bend, because that makes the cover fit perfectly. When you look off to the side, you don't see any exposed lugs for positive, which is good. And negative is the same. Looking good so far. All right, we're in the front of the engine, and this is going to be the same process as the back. Hey, before I pull this engine fastener out, there's a washer right at the bottom, so make sure you catch that. Don't let it fall out. The engine fastener bolt is about 5 inches long. If you're looking for lugs, a 1/4 inch works great. The Bussmann circuit breaker is a 1/4 inch stud as well. I'm trying to make a good mount so I can stand on the engine with the crimp and push on it, because I don't have enough leverage and I don't think I'm strong enough. I'm gonna try, but this is my alternative plan. All right, let's make the circuit breaker to the engine fuse positive. There's an open slot on the back. It's a 5/16 lug. The breaker is a 1/4. I have some extra cable that I cut off from the back and the front wire runs. So let's see which one fits. All right, here's the cables and the lugs and the heat shrink. Everything's cooling down right now. It's a good idea to use some rubbing alcohol and make sure that your surfaces where you're going to connect your lugs are nice and clean. I had to do this first because this cover has to go on. And once the cover's on, then I can rest the breaker on top. I just connected the jumper going to the engine fuse block positive. I put the lid on and I can mount the circuit breaker on top. This is an M6 bolt coming off the battery. In the previous part, that positive block was an M8. So let's get connecting. The circuit breaker only comes with a nut and a lock spring. Now, for extra safety, I'm thinking of actually taping around this section as well. Right here to cover the positive and over here to cover the positive. The positive side is all done. There's one more connection. It is the ground that goes to this engine block fastener bolt. All right, it's magic time. Let's test voltage. Battery positive, 12.38. Jump over here to battery on the breaker. We should have the same reading, 12.38. Now on the breaker side, we shouldn't have anything because the breaker's off. Now we can turn it on. Hopefully nothing sparks. Ooh, it's a good sign. Breaker on the aux side with ground at 12.38. Good. So now we can go in the back and check the back of the bus bars in the truck bed. Okay, here we go, ready? All right, 12.38 volts. That matches the front. For now, we're good. Let's go to bed. I did some temperature testing on the lugs and also the engine block because feeling in there, it's super hot and I got uncomfortable with where my ground location is. I'm gonna run my ground location to right here. I should have enough room. I found my spot. We're definitely going to use the frame area, but the way my cable sits, the lug will not sit flush. So I'm going to file a little bit of this plastic battery box. Just showing you my progress. Wire snips work the best to snip most of the plastic, and then you can use a file to make it smooth. The reason I had to move the cable to the side is because this gas strut for the hood, it was gonna pinch all the way. So if we test and take a quick look, we have plenty of clearance. Now this is my negative connection. Now we're done. Here's a quick look at the negative connection here. This is the positive connection. Those little 14 gauge are for the upfitters I still have to get to. Here's my 120 amp breaker going to battery positive fuse block, connecting to the battery bank. Hey guys, today is load test day. I'm gonna use this 2000 watt inverter, 2 gauge that I will cut into 2-foot sections to make my jumper cable, wire lugs, spools, and my heat shrink. Now, as a safety reminder, wire sizing and fusing. This setup is not meant to run a full 2000 watts. My breaker is set to 120 amps, and I've sized everything with a voltage calculator using the Blue Sea circuit safety website. So there's a voltage calculator and then also a fuse recommendation after that. Depending on size and your voltage, how many wires go in the bundle, how long you're going to be running the load, what your amps, you get a result of your output, your expected wire, and your expected fuse. So I went with 2 gauge and 120 amp. All that being said, I'm going to plug in, we're going to put some load on it and test it out. All right, let's start it. What you just saw was the truck starting and then the alternator kicking on, and voltage was reading about 14.14 volts. I'm gonna go over there and read the clamp real quick. It says 91 amps. Quick update on the truck, we're at 13.94 volts. The clamp meter is around 79 amps. The truck voltage right now is at 14.77 volts. The clamp meter says about 50 amps. While I set up the load test, I'm gonna turn off the truck, save some diesel gas. Prices are pretty high right now. And then when I'm ready to go, we'll start up the truck again and do an inverter heat gun test. Kill this truck. Boo! Final look at the setup before we get going. Heat gun, I have a kilowatt meter, backlight so we can see. Inverter's registering at 12.8 volts, 3.8 amps right now on the clamp meter. So now I'm gonna turn the truck on so we can have engine running, alternator running. Once we turn on the inverter, take current, decrease voltage, and then at that point, I'll take some voltage readings at the front of the engine and the back. Keep an eye on this clamp meter. I'm gonna start the truck. Right now, the 3 to 4 amps usage coming from idle inverter and then some truck lights. Starting right now. So right now on the clamp meter, you're seeing about 30 to 40 amps. Inverter is reading 14.5, and if we look at the kilowatt meter, we should have 60 hertz frequency, as well as close to something in the 120 volt range. This is looking good so far. All right, starting heat gun. Well, I can tell right away that the fan does not sound normal. And look at the output, 200 watts. I've only tested this inverter one other time, and I also got really bad mixed results. It came out of another pop-up camper, and I don't really know if it works or not, but it's worth a shot. We may have better luck just testing the compressor, guys. It's pretty disappointing. I'm pretty disappointed with that inverter, so we'll have to test for real when I get the compressor hooked up. Before I stop tonight's test, I'll show you some temperature probing, which is why I was concerned with the engine block. Right now, it's about 83 degrees Fahrenheit outside. I'm probing battery positive, 90, well, it's fluctuating a lot, 95. Battery negative, also at 90. The ground location where I finalized for the negative, 87, so 3 degrees less. Now let's catch that engine block section where I first had my lug. Ready? 125, 130, 135, 138. Keep in mind, as the engine's closed, all that heat just traps in there. So I'm glad I moved my negative to here. I think with the ground parallel and traversing back, we should have plenty of safety for that ground return path. Let's shut the truck off and call it a day. I know, the truck's yelling at me, but I think those are normal sounds. Thanks for watching part 2 of the onboard air system install. Stay tuned for part 3, where I get into the upfitters and I make the connections and do some load testing. Make sure you hit like and subscribe and stay tuned for more. See you guys.